Right, so we have the basic oscillator down, so it's being powered by 5 volts. And as you can see, we do get the periodic trace. It's not exactly stable, so see if I touch it, I can change the period of the waveform. But it's not a precise timer, so it doesn't really matter. All we want to do is get a periodic waveform, so when we couple it capacitively, we can get an AC voltage, and that will go into the diode ladder, and then we'll be able to extract a negative voltage out of it. So as you can see, it's being powered by 5 volts now. And when I touch it, okay, so I did change the schematic a tiny bit. So originally it would only provide a negative voltage rail, but I wanted to provide the positive rail as well from the same floating point. So I have 2 capacitors. So it's just, instead of going straight to ground like it did in the schematic, we just have a capacitor across it now. So as you can see, when I attach the probe to the negative rail, we get a voltage of negative 2.1 volts. And when I attach it to the positive rail, we get a voltage of about 2.5 volts as well. So this makes sense, because we're getting about 5 volts input, and it's going to divide it by 2. There's going to be a small drop from the diodes, but otherwise they're pretty negligible. The only difference this has though is because we're not using the plus minus 6 volts, we're probably going to have to put a fairly high gain amplifier on the output of the Hall effect sensors to make it work. But otherwise it should be fine. The negative voltage rail is done, so you can see that we have the 4 block connectors there to go to each of the 2 Hall effect sensors. Right now we've only got one of the Hall effect sensors plugged in. Then after that we have a quad op-amp package. We've only got 2 of them used so far, so this is going to be the initial gain. And I'm basically hoping to test the initial gain before we move on to doing the secondary gain. So if all goes well, this will actually work and we'll get a signal output. So I'm gonna see if this works. Okay, it doesn't seem to be working at all. Unfortunate. I have to figure out why it's not working. I have a feeling it's going to be due to these 2 capacitors, which probably aren't coupling the signal into the op-amp. So I'm going to come back to this and see what's wrong. So I just modeled everything out in Spice again to try and figure out what was going wrong. And I think I have a schematic which should hopefully work. So in the lab at least, I was just assembling things haphazardly and I hadn't planned anything out. So this time it should be fine. So I run a AC sweep on this schematic going from 0 to 50 millivolts. Oh well, it should be 50 millivolts. It seems to be negative 20 millivolts to 20 millivolts, which is fine anyway. And you can see that we have a gain of 10 and it's being amplified to 500 millivolts, which is what I want because I want to have a second stage after this with a trim pot so you can control the gain. So then you can have that feed onto a Schmidt trigger to clean out the pulses. So this seems to be working, at least through the simulation. There are problems where I can't simulate the noise, because there was a lot of noise as well, because the power supply, or the voltage references I was using for the Hall effect sensors, they were being provided by the oscillating Schmidt trigger. So there's quite a bit of switching noise, because I think that thing was switching at 24 kilohertz. But hopefully it should be fine. I was looking at these oscilloscope traces and there did seem to be a decent amount to be amplified, not just the noise, so it should be good. So if I have time, I will try to get this implemented tomorrow, and if it works, it'll be great.